All right, so in this section, we're going to talk about caustics. So the way we're going to get caustics is through a method called photon mapping. And basically what that's going to do is actually fire a bunch of photons from our light into the scene. And these photons are what are going to trace our rays, essentially. And when dealing with caustics, we will basically be emitting our photons from the light and reflecting or refracting the photons through the scene or through our object and back out onto other reflective surfaces or onto diffuse surfaces where they'll be visible. So when dealing with caustics, the first thing we're going to want to do is make sure that we're in bucket rendering mode because it will not be visible in progressive rendering. The next thing we're going to want to do is make sure we either have a glassy refractive material or some kind of metal reflective material in our scene. And then we're going to go ahead and drop a light in. On our light, we want to go to the Photon tab and enable Emit Caustic Photons. Now by default, the number of photons to emit is going to be pretty low. I think it comes standard at 100,000, which you'll see is not nearly sufficient at all to gather a usable result. So what we're going to need to do is crank this number up to say something like 2 million. And you'll see that we start to get a little bit of a clear result. Now there are ways that we can smooth this out, which we'll look at in just a minute. But first I actually want to go take a look at what our material options are doing to have an effect on the way that we scatter these photons. So I'm just going to quickly look at the refraction tab because in this case we're making what looks like a glassy prism, and we'll see that if we change our IOR, it's going to drastically change the way that our light bends, just as would happen if we were changing the material in the real world, which is pretty awesome actually. The trouble is it's actually pretty tough to trace because it requires so many photons to get a clear result, which is why generally photon mapping is not used for anything. I've also set up a dispersion value so that we get some of this fringing in our colors, splitting of the spectrum, which looks pretty cool. And if I change that, you'll see that we end up changing how much the rays appear to be splitting, the light rays. Alright, I'm going to dial that back down to 1.3. I'll keep dispersion at 0.5. And let's go check out our render settings real quick. Now if we take a look at the Redshift Photon tab, we'll see Enable Caustics is ticked by default. And we have a couple options here that are going to help us sample our photon map. And the way we're going to do that is with max num caustic photons and our caustic search radius. So max num caustic photons basically just says for each pixel, here's how many of these photons you can look at maximum. So at maximum, we're going to be using the results of 50 of these photons to render one pixel. As well, caustic search radius describes a search radius around a pixel that we're looking at and says only search within this distance around the pixel. So if I make this caustic search radius very high, you'll see that our result smooths out a little bit, but we also darken the results quite a bit because now we're searching a greater radius around each pixel, which will almost have a bit of a blurring effect on our caustics as well. So really the only way to handle this situation is to increase the number of our photons even further. You'll notice if I come over here and take a look at my unified sampling, this actually is going to have no effect on our result whatsoever. You'll see if I change our samples min and max down to 1, the only thing that it has a resulting effect on is our glass material. But for now, that's not really going to matter because we're only interested in checking out these caustics. So in order to clean these caustics up even further, we're just going to have to keep cranking up our photons. And I'm going to crank it up to something like 5 million. You'll see that we've cleaned up a bit, but it's still quite grainy. And that's really ultimately the trouble with photon mapping in general, is that you actually need to emit quite a number of photons in order to get a clean result. So now you can see with a number of photons to emit from our single light set to 10 million, we're starting to get some smooth results, which might be smooth enough to run some denoising on and get a usable result. I'm going to go ahead and set this back down to 1 million, which is going to give us a very coarse result. I'm just going to start rotating this to see the effect of what our angle that we hit this prism with, what kind of effect that has on our scene. You'll actually see that it's quite drastic, but we start to get some very cool effects just by adjusting our angles a little bit. So now something else that might help in this scenario is actually to tweak our material. If I set my dispersion down to 0, it might be a little easier for us to come to a clean result with a few less photons, because we're not splitting up our rays quite nearly so much as when we had dispersion enabled. So you'll see at 5 million photons, we're actually getting some pretty good results. The darker areas are still pretty troublesome, but our bright rays themselves seem to have resolved quite nicely. So one thing I did forget to mention is that in order to enable caustics, what we will have to do is add a redshift object tag to our object, go into the visibility settings, tick override, and make sure to tick casts caustic photons. Otherwise, if we do not have this checked, we're not going to get any photons cast from our object. So I'd really encourage you to actually mess around with this a little bit, because you can get some really, really interesting effects, and they're all very physically based. The one downside being that it does take a while to pre-process that photon scatter. However, you can get some really neat results. Anyway, thanks for checking out the Caustics section, and we'll see you in the next one.